Thank you for introducing. This is Kumanjo from Seongkyungwan University in Korea. Today I'm going to show you how we can improve the security of Android pattern locks. The main idea is this. When you create a new pattern, you should create the pattern with this yellow circle at any position. I'll explain the details in the rest of my talk. Traditional text passwords are used for many applications. However, the text passwords are difficult to type in mobile devices. So many alternative passwords have been introduced to replace current text passwords for mobile devices. Among them, the Android pattern lock is most popularly used to lock devices. However, it is questionable that Android pattern lock is a good option to replace current text passwords in terms of security. In 2013, the weakness of user-chosen patterns was reported. The guessing entropy of user-chosen patterns is lower than random 4-digit pins. And in 2015, the Kai paper verified the weakness of user-chosen patterns in the wild. These are top 10 most likely used patterns and look like easy pattern to guess. So there are many previous attempts to improve the security of user-chosen patterns. One is changing a grid layout that used a circle or random grid layout or bigger grid layout like 4x4. With those approaches, the password space dramatically increased. However, the user-chosen patterns were still guessable. Another approach is that people create a pattern with strength meter. The guessing entropy can be larger with meter support. However, from the result, the starting point was strongly biased. If an attacker knows this knowledge, he can easily guess a user pattern. How can he avoid this? We thought that the password polish for graphical passwords is one of the good options to solve this problem. Because the password polish leads to select passwords variously. How can we define the polish for Android pattern locks? To define the polish, we need to add some randomness. So we proposed system-guided patterns called SysPal. That is a novel system-guided pattern lock scheme. It mandates the use of a small number of randomly selected points, and users are given freedom to use those mandated points at any position, like this. To design the SysPal, we defined the 4 design principles. First, minimize the additional memorability burden on users. And second, keep the authentication time similar to existing Android pattern locks. Third, make it easy to learn and easy to use. And last, avoid significant software or hardware changes. And on the other hand, there are many known attacks against Android pattern locks. Here we only focused on guessing attacks with 20 guessing attempts. This is because if you fail to draw the correct pattern 20 times continuously, you may have this error message, too many pattern attempts. And this device permanently locked. Okay, this is outline of my talk. First, I'm going to explain our methodology. We define 3 hypotheses. A first hypothesis is a pattern with 3 mandated points has significantly higher guessing entropy than a pattern with 1 mandated point. It means that if people have a more mandated point, they may choose more secure pattern. And second is a pattern with 3 mandated points has significantly lower memorability than a pattern with 1 mandated point. Both hypotheses indicate that more mandated points improve the security but reduce the memorability. And last one is a SysPal polish has statistically similar memorability to original Android patterns and better security. The user study and experiments were designed to validate those hypotheses. These 5 polishes were used for our user study. The first one is original, that is existing Android polish. Then last one is random, that is a system-generated random pattern. And these are SysPal polishes. And each polish defines the number of randomly selected mandated points must be used once upon selecting a pattern. So I will explain how we designed the user study. The first large-scale study was conducted using Amazon Mechanical Turk, recruiting 1,717 participants. We developed an Android application to evaluate the SysPal polishes in a realistic setting, and participants were asked to select a pattern under one of the 5 polishes, and the polish was randomly assigned. Using this application, we collected participants' data to examine how they choose pattern and use it to unlock their phone. And after finishing a pattern setup, we asked the participants to complete 2 remembrance training tasks to help them remember their pattern, and they complete an electrical puzzle to wipe out short-term memory. We follow up this methodology from previous research, and then they drew the pattern correctly with 5 chances, that is a first test recall, and they drew the pattern again after 50 minutes later, that is second test recall, and we invited them after 24 hours, and they drew the pattern for third test recall. So from now, I will show you the main result of usability and security. First, usability result. From 3 recall tests, we measured recall success rate. All SysPal polishes are similar recall success rate to the original polish. Even 2-point participants recalled their pattern more than original participants in the second and third test. And we also measured authentication time. The random participants took a long time to authenticate their pattern, and original and all SysPal polishes are similar, and there is no statistically significant difference. And we analyzed number of attempts. The random participants drew their pattern twice on average, and that could be a significant usability issue. And again, original and all SysPal polishes are similar. About the pattern setup time, the differences between the original and all SysPal polishes are not statistically significant. Only random polish is statistically significant with other polishes. And the security result, as I mentioned before, we want to deal with the biased starting point. About 65% of original patterns started from the upper leftmost point. Unfortunately, all SysPal polishes are similar. However, the ratio is quite decreased and statistically significant difference. We thought that this is because we allow the participants to reset their pattern when they create a pattern. If they did not have a chance to change their pattern, maybe the starting point more evenly distributed. And we analyzed the frequencies of the segments used. We defined the segment as a line that 2 points connect together. The darker the color, the higher the number of segments used. 1 point polish is more evenly distributed than the original polish. And all SysPal polish participants were asked to use mandated points. They used the mandated points mostly in the first position of their patterns. And interestingly, 2 point participants used the first position frequently. We thought that one of the mandated points could be used frequently as an ending point because they create a pattern with pattern length for about 30%. On the other hand, the frequently occurred patterns can be easily guessed by an attacker. We collected total 1,717 patterns, which is not sufficiently large to calculate guessability of patterns. Therefore, we estimate the probability of all possible pattern occurrences by using 3-gram Markov model. Our study results showed that SysPal is indeed effective in strengthening Android pattern lock security, and the pattern lock generated with SysPal polish have higher guessing entropy. And 20% of patterns generated with original polish could be compromised within 10 guessing attempts. Otherwise, 1-point polish, the numbers goes up to 53 guessing attempts. Here, we note that, as you can see this graph, the 3-point polish was not good as much as other SysPal polishes. It can be seen that the increasing point is not helpful to improve the security of Android pattern locks. And to crack the pattern, we made a list of ordered patterns based on 3-gram Markov model as a pattern dictionary, and tenfold cross-validation method was used to crack the collected patterns. About the result, about 32% of original patterns were successfully cracked within 20 guessing attempts. All SysPal polishes were cracked less than original polish. Again, 3-point polish was not good as much as other SysPal polishes. However, our first study has limitation because people unlock their phone more than 3 times per day, so we cannot strongly claim about the memorability. To address this limitation, we conducted a field test with real-life scenario. A field test was conducted at our university, and same methodology was used, but we experimented with just 3 polishes, and participants were asked to use a pattern lock application for 24 hours. We developed a pattern lock application for the field test. With this application, a lock screen is automatically popped up when participants turn on their phone because the application runs in the background of their phone. About the result, all polishes showed high memorability, and both authentication and setup time, the all original polishes outperformed 1-point and 2-point with statistically significant difference. And all participants unlocked their phone every 22 minutes on average. The longest period is about 11 hours. That is a sleeping time. And discussion, we defined the 3 hypotheses. And first one is about the security improvement. Increasing the number of mandated points did not improve the security of all SysPal patterns. And second is recall success rate and memorability effect. The effect of increasing the number of mandated points is unclear, not enough evidence to accept the second hypothesis. And the last one is replacing the original Android polish. About the memorability, none of SysPal polishes showed statistically significant difference against the original polish. In terms of security, all SysPal polishes outperform the original polish. Therefore, SysPal polishes can potentially replace the current Android polish without compromising too much usability. Many graphical passwords have been introduced in both academia and industry. The SysPal could give useful insight and guidelines to develop future graphical passwords. So I'm going to conclude my talk. SysPal can improve security of Android patterns without compromising memorability, and 1.0 or 2.0 is a strong candidate to replace the existing Android policy. And finally, I would like to say this. We hope that our SysPal will be included in the next Android version. Thank you for listening. And any question?
Thank you. Question.
Hi, yes, Alex Gampman from Qualcomm. Hey, a question about the subjects. Because you had a recall component, right? People had to come back 15 minutes later and 24 hours later. I'm assuming some people just didn't come back.
Yeah.
Did you see any correlation with, like, for which scheme people would drop out more?
Actually, we have. This is the we calculate the memorable record success rate without the people who did not return the second or third test.
So okay, so did they basically not come back more for the 3-point?
Yeah, this table without the not returned participant.
Okay, thanks.
This is a very good suggestion, so maybe we need to consider the correlation value. Okay, thank you.
Thanks.
Ben Fuller, UConn. Can you provide a hypothesis as to the non-monotonicity of like all of your data? Like it's not just one axis, everything is non-monotone. So like security and usability is fluctuating up and down. Is it just not statistically significant, or like is there something about the fixed universe size of 9 points? Why would you expect usability to go up and then down as well as security to go up and down?
무슨 말이죠? 이거 말하는 건가?
Okay, with what hypothesis did you mention? Which hypothesis?
I think he was asking about the irregularity of your data. Sometimes data just shows security goes up, sometimes goes down.
Mm-hmm.
So like why would 3-point be less secure than 2-point?
Oh, actually, we evaluated the security pattern based on some cracking results and also caching entropy. So we found that the guessability of our policy with 3 mandate point is not higher than our policy with 2 mandate point or 1 mandate point. So we cannot accept this hypothesis.
So given that even with your technique, users are still using the upper left-hand corner quite a bit, have you considered biasing the placement of your mandated points so that you can get the user to basically avoid the upper left-hand corner using it so much?
Okay, thank you for the question. Actually, our policy cannot solve a bias problem totally, so we believe that this is just good starting point. So probably we also need to consider another type of pattern policy. So in this case, maybe we can solve this kind of issue. Thank you.
Thanks, very interesting talk. It seems like the starting point is very important for the attacker to guess the pattern. So have you considered, like, instead of just choosing mandate point, have you tried to consider mandating the starting point for the user? Like choose a random point for the user to start?
Actually, we want to give users freedom to use those mandated points. We thought that the other type of policies is solve this problem, like the mandated segment is one of the options to solve this problem.
And also, some researchers already tried to use starting point as a mandate point. So definitely we need to compare our policy with theirs. So this is also one of our future direction. Thank you.
Thank you.
Okay, let's thank the speakers again.